All right, so in this video, we're ready to talk about polar graphs. So we'll take a look at the first example here, r equals 2 secant of theta. And this is just one method in determining the graph. The more that you do of these, the more comfortable you'll be without having to go through a big, elaborate process in order to figure it out. But seeing as this is an introduction to polar coordinates, we'll go through this pretty slow. So in the first example, I'm going to go ahead and say that this is 2 over cosine of theta, and if I multiply the cosine to the other side, I get r cosine equals 2. Well, r cosine theta is actually x in the rectangular coordinates, and so what we find out is that r equals 2 secant of theta is the same thing as x equals 2. So the graph here, if this is the x-axis and this is the y-axis, would look like this. And that would be the same graph you'd find by plotting a bunch of points, which we're not going to do, plotting a bunch of points in the polar coordinate system as well with all of those concentric circles. Now, the next example is pretty similar. This is the same thing as 2 over sine of theta. And if I multiply the sine over, I actually get y equals 2. So in the rectangular coordinate system, it's very easy to see that that's going to be a horizontal line at y equals 2, but seeing as this and this are the same, even in the polar coordinate system, you still end up with this line. Again, if you were to plot a bunch of points and on those circles, you would end up with the same exact graph. As you can see, it's much easier to understand it in terms of x's and y's, mostly because that's where our familiarity is. Okay, so now in this next example, we're going to be asked to graph theta equals pi over 4. And I want you to go back and think about something for just a minute, though. When we graphed x equals 2, what were the y's? Well, the y's were anything. The rule said x had to be 2, but y could be anything it wanted to be. Similarly, when we graphed y equals 2, what were the x's? Anything. Y had to be 2, but x could be anything. So here, all we find is a theta having to be pi over 4. This means that r is anything, or r is unrestricted. So I'll come over here now to our polar graph and plot just a few points, and this can be done very, very quickly. So if r is 0, we're still at the pole no matter what theta is. If r is 1, we move over to the first circle in the positive direction, but we then move to pi over 4. If r is 2, we're at the second circle around to pi over 4. If r is negative 3, remember, we go 1, 2, 3, and then we have to go in the positive direction, pi over 4, which is going to put us right here. So you can see, no matter what r is, if we move in the positive pi over 4 direction, we're ending up with points along a line. And so this is called a radial line. And in this case, it happens to go through pi over 4. So anytime you have theta equals a number, it's always going to be a radial line. I can verify this for you pretty quickly with a little bit of understanding that tangent of theta equals y over x, and our theta in this case was pi over 4, which equals 1. So if y over x has to equal 1, then x equals y, and that's the line, x equals y. So works out nicely in a couple different ways. So now in this example, we're going to take a look at r equals 2. Similar to the last one, this is where theta is unrestricted. So by, in our heads, just plotting a few points, if r is 2, we're always out here on this second circle. And theta can be anything. Theta could be pi over 12, theta could be 5 pi over 12, theta could be pi, if we're out here on 2, theta could be negative pi over 2. And so no matter what theta is, we just keep getting a bunch of points on the circle with radius 2. So anytime you see r equals a constant, it's just a circle with a radius of that constant. And similar to the last one, it's not very difficult to see. We know that r equals the square root of x squared plus y squared, which means 2 equals the square root of x squared plus y squared. If we square both sides, x squared plus y squared equals 4. And yep, that's the circle that we had graphed in red. All right, so for the next two graphs, we'll take a look at r equals 2 cosine and r equals 2 sine. Now, in order to get this thing going, I'm actually going to do is convert it back into x's and y's. So to do this, I'm going to take both sides and multiply by r. And that'll give me an r squared equals 2r cosine theta. And the reason I did this is because now I have some things I recognize. I can see that r squared is x squared plus y squared, and r cosine would just be 2x. So now, x squared minus 2x plus a y squared equals a 0. So all I did was I subtracted the 2x over, and you're probably taking the hint there by me doing this that we're going to complete the square and then see what this graph is. So half of 2 is 1, and we square it. If I put a 1 on the left, I put a 1 on the right. Left side will factor as x minus 1 squared plus y squared equals 1. So what we have here is a circle with a center at 1, 0 and a radius of 1. Now, what's interesting is, I'll call this 0 and I'll call this pi over 2 just to emphasize the polar. This ends up being a circle that looks something like this. There's your 1 and there's your 2. So now, when we see r equals 2 cosine theta, the x and the cosine are always kind of come together as a pair. So cosine would mean the x-axis, and that 2 means you have a diameter of 2. So hopefully you won't have to go through this process every time. You'll just be able to see, okay, cosine means x, so x-axis, and 2 is the diameter, so there sits our circle. Keeping that in mind now, when we look at this next example, we could do all of that same stuff. And it would work out to where you'd get x squared plus y minus 1 squared equals 1. But again, I don't really think we need to do that. If we understand that sine is part of, or is very much connected to the y in terms of polar and rectangular, then we can see that we're going to have a circle on the y-axis, and there's your 1 and there's your 2 for the diameter. So once you do some of these, and the more that you do of these, it's going to be easier to pick out what the graphs are without having to do so much of this every single time.